This is a ReactJS single-page web app running on top of a REST API backend deployed to AWS API Gateway and Lambda that manages requests to the OpenAI API. This project implements all 30 of the example applications from OpenAI's API documentation. I'm going to use our time in this video to explain more qualitatively what this code does and how you can take advantage of it for your own custom OpenAI API application. Keep in mind that AWS Lambda is where all the real action is. It manages the session interaction with the OpenAI API. It keeps your OpenAI API key safe. It validates your HTTP request. It creates coherent error responses for you, or at least that's the intention. It's written in Python, but just so you know, you could refactor the entire thing into Node.js if you wanted. And if Node is how you prefer to do things, then be aware that there's also a Node.js Lambda in this project that I added as part of the course workflow, and really just as an excuse to create scaffolding for you that illustrates how to set up a Node Lambda with Terraform. In either case, the Terraform code is pretty easy to follow, and it'd be really, really difficult to create on your own from scratch. So having examples in both languages might be really helpful. This entire project, front end and back end, is open sourced and it's available in a single, well-documented public GitHub repository. You'll find a link to the GitHub repository in the video description down below. The getting started instructions are very clear and the documentation is excellent. It's parameterized with Terraform TF vars so that you can build and deploy this to your own custom domain in just a few minutes using your own AWS and OpenAI accounts. What you're seeing, by the way, is a production-ready application, meaning it handles all possible responses from the API. That is, the good 200 responses, but also the not so good 400 and 500 response varieties. It's secure. It runs over HTTPS, and no sensitive data, like for example your OpenAI API key, is being publicly exposed. Additionally, all of your other credentials are also properly protected in the build deploy workflows so that they're assured to definitely not end up inside of the code that gets pushed to GitHub. It's scalable. It can handle any volume of traffic, your ability to pay the bills at OpenAI and AWS permitting. You could deliver this code to a client. The documentation's good, and it follows best practices for React, for AWS, Terraform, and good code management in general. It's maintainable. It's well documented, and where possible, it uses popular, community-supported open source components, and it's dry. I actually use this code base as a teaching tool for a university class and also as part of my portfolio, and so this provides some minimal level of assurance that the code that I'm about to show you actually works. Longer term, I envision using the OpenAI API Lambda that's in this back end to serve way cooler, way more sophisticated cloud services where I'll integrate customized ChatGPT requests into other structured content. So anyway, stay tuned to this channel for more good things to come. Okay, let's get into it. Our featured app for purposes of today's video is going to be Marv, the sarcastic chatbot. On an aside, and importantly, there are no running costs at AWS nor OpenAI for having deployed this app. It's strictly a pay-per-use costing model. So, no traffic means no cost from AWS nor OpenAI. And lest I forget to mention it, a few weeks ago I made an entire video about the back end for this project, so you might want to check that out as well. Look for the link in the video description down below. Today's video is not sponsored by AWS nor OpenAI, nor anyone else for that matter. I just like making videos. What we're looking at are two mutually exclusive projects bundled into a single code repo. First, and most definitely the coolest thing, a React app that's managed with Vite, but also a REST API deployed to AWS Serverless components using Terraform infrastructure as code. And if you're new to either Vite or Terraform, then this is a pretty good project for getting your feet wet. For that matter, if you're new to either React or AWS Serverless components in general, then again, this is a pretty good project for getting your feet wet. So first up, the React app. Architecturally, keep in mind, that what you're looking at right now is the combination of 3 popular open source React components. One, there's ChatScope's Chat UI Kit React, which handles 100% of the chat user experience. 2, there's React Pro Sidebar, which you can see here in the left sidebar, assuming that you're looking at the app from a desktop. 3, and lastly, React Model, which we're using to echo all the non-200 API responses back to the user in hopefully an intelligible format. You can deploy the React app however you like. It's super compact. Even with the assets bundled into it, it won't be more than, say, 20 megabytes in size. And in my case, I hosted it from AWS CloudFront, which is basically free. It's very easy to set up. And actually, the entire deployment for that approach is inside of the makefile of this repo. But there are plenty other good options out there as well, just so you know. App.jsx is basically just a bunch of boilerplate code. I think the only topic of interest for purposes of this video are these chat app definitions. These are JSON dicts that contain the complete configuration for each app. These dicts are passed in their entirety as a prop to a custom component named chat app. This, incidentally, is nearly all of this app. The core of the app is bundled into this component that basically does just 2 things. 1, it renders the JSX and related styling for the components from ChatScope's Chat UI Kit React. And 2, it handles all the rest of the UX stuff, like initializing the chat window, managing the file upload process, the error modal, the info button click, and of course the API requests themselves. Okay, now let's look at the back end. To get started, let's first take a look at the actual spec for our example application, Marv the Sarcastic Chatbot. Notice that the entire application spec consists of only 5 parameters plus the input. There's a Postman import file in the repo that you can use to set up and interact with all the REST API endpoints for the entire React web app. In example 15, Marv Sarcastic Chat, notice that the only thing we're actually providing is the user's chat prompt in the form of a key called text_input. Thus, the other 5 input parameters are obviously being sourced in some other way, and we'll revisit that momentarily. But beforehand, let's zoom out for just a second and take a look at what the OpenAI API needs to receive from us in aggregate in order to create the Marv the Sarcastic Chatbot. Ultimately, we need to pass all 6 of these pieces of information. So I created this ancillary pass-through endpoint for dev and prototyping purposes, and it's really useful for situations just like this. Here, with this endpoint, we can exactly duplicate what we see in the OpenAI API example application spec for Marv the Sarcastic Chatbot. So, with the benefit of that knowledge, now we can move to Terraform and AWS to see how the back end for Marv the Sarcastic Chatbot is actually implemented. First, the Terraform code. This is how each of the 30 applications are implemented. So effectively what I did was I created a module that's called endpoint that you'll find inside of this Terraform folder, and we're calling that. And then inside of that module, we're passing the other 5 key pieces of information, which effectively are the definitions for each application. Let's go inside of AWS console and look at API Gateway. Of these 6 boxes, the only thing that's of interest is the integration request. If we look at the integration request for Marv the Sarcastic Chatbot, then what we're going to see is down at the bottom here, in the mapping templates section, we will see that Terraform has created a mapping template for application JSON request types. So provided that that content type header has been placed in the request, then API Gateway will apply this mapping template to the request that comes in. Sidebar comment, it's necessary both in Postman as well as in the React app. If we look in the headers section for Marv the Sarcastic Chatbot, you'll see that we're placing a custom header for content type and setting that to application.json. And if I bounce over to the source code for the client, jump into the source, and we go down into the components, chat app, and here in API request.js, we'll see here as well, we're setting some custom headers. Basically, we're setting the same 4 custom headers in both cases. And importantly, this content type is being set with application.json. And that is what causes each of the HTTP requests to get this mapping template set. Now, so here's what it does. The first part's clear. We've got those 5 pieces of information that you saw in the Terraform definition for Marv the sarcastic chatbot. So here's our setting for the model, the GPT 3.5 turbo. You see the 0.5 temperature, the 256 max tokens. And then for the input that's collected both from Postman as well as our app itself, whatever it is that we're typing in here, this can be picked up using this special system variable that's part of the API Gateway platform. And so there's some documentation, there's links inside of the source code that you can follow to learn more about how that works. But effectively, we're going to grab the text from this input box and we're going to place that text here in the user role. And that will give us the complete JSON dict that looks just like what we see in this pass-through. Now then, there's a lot of minutia that actually makes this API work well. And so just be mindful that we're glossing over a lot of details that you can and should discover on your own time in the AWS console and in the Terraform code. Okay, so let's summarize what's happening here. The single input key input text is being passed to API Gateway, whereupon it is injected into this static JSON body that was created for us by Terraform, thus creating a complete JSON dictionary that looks exactly like the one that we created in the pass-through. But what did we actually accomplish by taking this approach? You know, by creating this entire extra, quite complicated layer rather than simply calling the OpenAI API directly from the React web app. So first off, 2 quite important things. The application backend is being abstracted and removed from public view. So that is the how it works part of each one of these applications is now embedded inside of your AWS serverless backend rather than being publicly exposed. And B, and perhaps a lot more importantly, your OpenAI API key has also been removed from public view. Now it's embedded in your Lambda as an environment variable out of public view. But we've also achieved some important architectural goals as well. We've taken control of validations and error handling code. We now have detailed logging with CloudWatch for audit and troubleshooting purposes. The CORS policy is now under our direct control, and importantly, we now have a strong foundational framework that we can grow in the event that in the future we want our backend to do more than simply make calls to OpenAI and then return its results to the client verbatim like what you see here. Now, of course, it shouldn't go unsaid that we're also benefiting from the luxury of running our stuff on fully managed, highly reliable, infinitely scalable serverless gear like API Gateway and Lambda, and it's basically free until the platform begins to scale. And that's it. That's all I've got for you today. There are a dozen other videos that I could and should definitely create on the same code base. So leave me a comment below and let me know what you want to see next. And while you're at it, don't forget to like and subscribe so you can see more great videos just like this. And I'll see you in the next one.